Hello, my name is David Ackerman, student number 220310629. The date is 23rd of September 2024, and this is the W3 video assignment for thermodynamics. So in the assignment, we are given the Art 134A at state 1, which these are the given values, which are written down here. So the problem states that we have to show a TV, which is a temperature specific volume diagram, and then calculate H1, H2, and H3. This is the diagram where here we have stage 1, stage 2, and stage 3 shown. Here we have also this in the blue line, we have the saturated temperature, which is negative 10 degrees. It starts off at negative 12 degrees Celsius, as shown by the state, because it's one of the temperature one, and it ends off at 80 degrees Celsius, which is temperature 3. Now, this is stage 1. Stage 1, it starts off at 12. The pressure 1 is 0.2 megapascals, and we don't know the volume, the volume 1. When we add heat, it goes into volume 2, which volume 2 is 25 volume 1, which is given right here. And pressure 2 is still the same, which is 0.2 megapascal. And when we add 3, the volume 3 equals to the volume 2, and the temperature is now 80. So here we have B, which was now we're working through the stages. So the saturated temperature is P1, which is 0.2. The saturated pressure, I'm sorry, is 0.2 megapascals, which it converts to um, 200 kilopascals, and this is the conversion. So here we can look at stage 1, which temperature 1 is less than temperature saturated at 200 kilopascals, which this would mean that it's a subcooled liquid. This is given right here, negative 10.09. Because negative 10.09 is greater than negative 12, this would mean that it's where stage 1 is within the subcooled liquid region. So H1 is roughly HF at negative 12 degrees Celsius. And this would mean that we have H1 equally to 35.9 kilojoules per kilogram, equaling because we used table A11 for this. Now V1 is roughly VF at negative 12. And yet again, we used table A11 for this, which is this number right here. And we would get 0.0007498. This would be useful in the later stage. So this is H1. In stage 2, volume 2 equals 25 V1 as given by the initial condition. So 25 times V1, which is this number here given right here, we would get 0.018745 meters cubed per kilogram. And we know that we're in the saturated mixture region because HF is less than the VF is less than V2, which is less than VG. This would mean that we're in the saturated liquid. Now, because we're in the saturated liquid, we have to find the X value, which is the vapor percentage within the mixture. So now we're going to use V2 minus VR 200 kilopascal, VR at 200 kilopascal, divided by VG 200 kilopascals minus VF 200 kilopascals. And we can use the table A12 to find all these values. And once we find these values and we simplify it, we're going to get 0.18155. Or in other words, 18% is the value of X2, which is the ratio for vapor. Then we have H2 equals to this formula here. That was this formula here, which is HF at 200 kilopascals plus the ratio that we just calculated for the mixture, HFG at 200 kilopascal, which is then yet again given by table 812 because 200 kilopascals is right here, and these are all the values that we're going to be using right here. And um, once we compute all these calculations, we get 75.86 826 kilojoules per kilogram, which this is H2. Now we're going to move on to stage 3, which is given by the condition that V3 equals V2, um, we're going to have the 0.0187425 meters cubed per kilogram. So at temperature 3, which is 80 degrees Celsius, which was given to us by the original question, VG at 80 degrees Celsius is this number here, as provided by this table right here, which is A11. 80, as you can see, this is 80 degrees Celsius. Continuing, um, so we're in the superheated vapor region because volume of 3 is greater than VG, which is 0.06. So this number here is greater than this number here, meaning we're in the superheated vapor region. Now we have to find out the H3 by building up a ratio. Now here we have an assumption. The assumption is that it's progressing linearly between these terms because we can't find we need to find the value in between uh, 1.2 and 1.4. We're going to assume that that value is right in the middle, which is 1.3. So we're going to assume that it's progressing linearly. So we're going to assume equal right angle triangles, and we're going to build this ratio here. Once we build this ratio here, then we simplify for H3. We compute all the calculations, and we get the value of 309.87 kilojoules per kilogram. Therefore, the three heights would be H1 equals 35.9 kilojoules per kilogram, H2 would be 75.826 kilojoules per kilogram, and H3 would be 309.87 kilojoules per kilogram. This would be the final answer. Thank you so much for listening to my video.